Thank you, Boo. Thank you for audience still here. Today is more detail about how our AI system, work with the small bowel capsule. So everybody knows, one of the large obstacle for the capsule is reading time. It's just take anywhere from 20, 30 minutes or even longer, typically. So here, every capsule, once it's swallowed, in the small bowel, it produces tens of thousands images. So here, we have developed a platform. It consists of one Navican engine. It's a high-performance GPU-based hardware platform, and also a convolutional neural network-based algorithm. So working together, it will screen out all those tens of thousands images down to maybe hundreds, all the positive lesions. Here, just give you a typical example of the lesions. Give an example of one, the image A. On the left, it's original image. Then in the middle, it's the heat map produced by artificial intelligence algorithm. On the right, it's a merge of two images. Here I just give you a brief review about clinical study we did together with gastroenterologists. So the aim of the study was the design goal will be to produce the highest sensitivity to screen out as many as possible lesions as possible. The data source is incredibly high. I mean, it's out of more than 113 million images from 6,790 patients who did the small bowel capsule endoscope at 77 medical centers over 2 years. So the results were published last year, October. Gastroenterology, it's the cover page article. The comment was from the editors. So it says it opened a new era for diagnosis of small bowel disease. I give you, some detail about, how we did the training of the algorithm. So the training data were from 158,000 235 for small bowel images from almost 2,000 patients. The method that we did for labeling, we categorize as normal, inflammation also, and all kinds of lesions. Here I want to just give you more about what's the principle of annotation. For each type of lesion, we would include at least 1,000 images. The image has to be high quality. It's clear, no dark or overexposure. And we want to make the lesions as much as possible to centralize and big enough. So the label will be done separately by two doctors. And also we want the lesion, if they two different type of lesion on the same image, we will treat it separately. We use 5,000 video from 5,000 patients with more than 113 million images to validate the AI algorithm. So we used, 20 gastroenterologists. They routinely perform small bowel capsule endoscope examination and evaluation. They use them to do this validation. So here I can show you, how we did the validation. We include 5,000 patients. There will be just like head-to-head comparison. Your same video will be sent to one group of 20 doctors for the conventional reading. And the same video would be sent first to the algorithm, to the AI-based algorithm for reading. Then the results, definitely you will come out with coordinate positive and coordinate negative and discordant. So for those discordant, it will be the 20 doctors will be sitting together. They will just everyone confirm This is whether it's a negative or positive, or it's a normal, it's abnormal. So the consensus evaluation will be done by the 20 doctors together. That's the gold standard. Here is the results. The reading time will reduce the significant time. Here, because the doctors, once they were doing the routine review, they knew they're competing with the AI, so they even spend extra time. So this is abnormally long, like 90 minutes average. But nevertheless, the AI algorithm would reduce the reading time to less than 6 minutes. Then let's see what's the sensitivity. So here on the blue box, it's the sensitivity per patient analysis. That's close to 75%. The AI algorithm would give 99.88%. So for clinician analysis, the sensitivity from the conventional reading is about 77%. The AI algorithm would give 99.9%. Then you look at what kind of positive lesions come out. Here is a total lesion out of the conventional reading. The AI algorithm screen out about 1,000 more total positive lesions. Here is all different type of lesions. You see from this table, on every type of lesion, the AI outperforms the conventional reading. So then, we did the engineering-wise, based on the clinical data, on the clinical work, the company developed a platform we call Navican engine. So this engine consists of hardware and software. The software, we have a unique Navican pulse scan feature. It's based on the GPU hardware. So here is the video how it works. So this is just the conventional reading interface. Everyone doing the capsule reading. You're probably familiar with this. So you are basically spend time maybe 30 minutes or more on this the entire video. Here then in our software interface we have a pulse scan feature here. If we click that, it will quickly give you all the positive lesions screen out and reduce the image substantially. Then this data will be presented to doctor for you to decide whether it's true positive or not. That's very handy for using. So to summarize, the CNN or the deep learning-based auxiliary model identify abnormalities with a very higher level of sensitivity and significantly shorter reading time than conventional reading. So this algorithm provides an important tool. We can help doctors to analyze small bowel capsule imaging with more efficiently and more accurately. So that's basically conclude my talk today. So this is a disclaimer. Thank you.